G'day everybody, Brian here from quantlabsnet.com. I am going to talk about doing what I've been doing in Python, showing you simulations, dashboards and whatnot in Python. I'm going to talk about my experience so far with now C++. This particular one and C++ is kind of hard to work with. I'm only doing this to sort of prove that you can do this with C++. It depends on your LLM. You probably have to use a more recent one to keep up to date and better output of the code. I'd still say Claude 3.7 is still the way to go. And also going through the iteration process to remove bugs and errors is a lot more work. And I would say probably 2 to 3 times the effort. The other thing is when it comes to C++, doing it with the front end, the third-party front end, it's not worth it. It's just bigger code, more problems, compatibility problems with your Windows system or wherever you're going to host it, Linux, whatever. So I'm focusing the C++ on uh, console apps, terminal apps, and they don't really have an interface, no front end to them. The thing is, wherever you run it, you want it to connect into your broker software. It has to be in the same environment. So if you're doing this on, let's say, Windows Interactive Brokers (TWS), you need to have it hosted. The application C++ has to be hosted in the Windows. If you can run it in a WSL on a TWS, host it in a WSL, you can do that as well. But mind you always remember that the Linux versions of TWS will be quite a few major versions behind, I believe. That's been my experience. So you might be wanting to use the TWS on Windows if you can. So let's go into this and a couple other things when it comes to C++. I have tried to work with both Visual Code and VS Code in C++. I'm gonna honestly tell you, I find it just bloated crap. There's just too many configuration files with both VS Code and Visual Studio. I find it very difficult to rebuild projects from uh, the. Yeah, here, I'm going to get rid of this. Okay. Yeah, it gets kind of hard to focus with all these extraneous JavaScript or whatever other configuration files. So as a result, I just work with CLion from JetBrains. I find it just cleaner, less configuration crap, and I'm also used the standard CMake as well. So this is all the code for what I'm going to show you. Um, it's pretty surprising. I can run this in Windows, so it's in release mode. Um, and where do I find my? So I can run it here within the environment of CLion, um, no problem. Okay, so this is the I'll show you the details of this app. It's kind of cool actually. But you have a menu set of options here. I'll go through this, but just want to show you can run in the CLion IDE on Windows. Once you take it out, it starts complaining about needs these system libraries, DLLs, and all this other garbage. And it's a real pain in the ass with Windows. Uh, so maybe just maybe I might just go focus on Linux environment. It's just cleaner, just smaller code. I don't know what's going on at Microsoft to do all this over-engineered crap. So, anyways, I'm able to take all this code, which I did, okay, and then I moved into my WSL, exact code, exact code. So it's sitting here in my WSL, which is Ubuntu 22. Runs fine. So when I go into my WSL, remember that's Windows Subsystem Linux. So this is Ubuntu 22, as I said. So the process to build is standard, um, and just doing CMake and that process there. So here's my final bin file or executable file for that makes it run. So if I make it run like this, I didn't have to do any code changes. I didn't have to do any file changes to get this running within my environment here in the Linux. So that's why I'm kind of like, why do I want to be on Windows and definitely don't want to be on overpriced Mac or anything Apple related. I used to be a big fanboy a few years ago, but not anymore. Anyways, this is the app here. So right here, um, we have it can technically connect into interactive brokers. Um, and here you got a portfolio summary, things that I've shown in a Streamlit Python app, but this is on in a console app, and it's C++. And as I said, without the front end, it's better. And using it this way and connecting directly into your TWS software, Trader Workstation from Interactive Brokers, it's easier as well. So here's, you can see the portfolio summary, and this is what I prompt to generate this. This is 100% AI generated. And you can see what we're focusing on here is oil, silver, and natural gas. So this is what I showed a few days ago, actually to the Mumu finance audience through my meetups, which went pretty good, I think. Anyways, this is now C++. I just added in natural gas. So here you can see all the allocation percent wise on a I think this is a $100,000 account. I could draw it down to whatever I want. You'll see it in a minute. It's kind of cool. Anyway, so we have CL, silver, natural gas, 30%, 30%, 40% allocated. Here we have very specific um, instrument strategies that I have available based upon that Streamlit app. If you watch my video on that, and I identified uh, a bear put on silver, iron condor on natural gas, and iron condor on silver as well. And these are the expected returns over a month. And you can see here, I can toggle these strategies on and off. Okay, so let me just show you some of the available options here. Okay, so here I just showed you the portfolio summary. Um, Here's the instruments. So if I want to show you, I don't know, oil, and this is all again simulated, but I can uh, configure it to connect into Interactive Brokers, TWS, to download the latest market data. And this is all simulated, as you know, for now. So we have contract size of 1,000, tick size, current price, implied volatility, and that's all from my executive summary document that I'm able to also AI generate. And I put a lot of that now on my GitHub at Quant Labs. On my GitHub, Quant Labs, I've got 2 projects there. All these projects will be hosted on my website and only for my website visitors. So here you can see the historical prices as well. So there's that. Okay, so I could do back testing. These are back tested results actually. So these are because it's a text app console. You can see these charts trying to show the overall drawdown equity curve. I mean, I could generate plots using what's the one called new plot in C++. I could generate that if I wanted. Um, and then you can see here over the results as well, back tested, take profit, blah 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 blah. Okay, and then we get the Sharpe ratio as well. Also, going back to the main menu, so we could forecast as well, similar to what I've shown in the um, prior app, which is with Streamlit. So I can do it kind of here in C++. Okay, Sharpe ratio and all that um, as well. Okay, so here's the interesting thing here. So I could toggle the strategy. Okay, so when I say toggle the strategy, I've talked about this before. If I'm running this live, I can basically turn on or off any of these strategies. So let's say I want to turn off Iron Condor. Uh, what will happen is it will turn it off. And if I toggle on or go back to the portfolio summary, um, let's see here. Yeah, you can see Iron Condor has been disabled. So I can do that and it should reallocate all the available capital back into these two other ones as well. Um, but even if it doesn't, it's pretty cool that I'm able to do this in this massive prompt. The other thing is I can optimize the portfolio. So here is my allocation based upon the strategy types. Let's see here. Yeah. Okay. I think there's one more. This is the important one as well. So let's say if I simulate a portfolio with these particular instruments and the strategy types, I can now change my starting capital and put it down to 5,000. So I've simulated it at starting capital of 500,000. So now I can put it for live trading at, I don't know, 5,000, boom. And then if I go back to the portfolio summary, you'll see here my initial capital is back to 5,000 and then everything changes and you can see here the weight allocation adjusts to that new starting capital as well. And the thing is, this is all done by AI. This took about, once I got into CLion, I was able to generate this pretty quickly. But as I said, you got to go through a lot of uh, iterating to correct the code, and that took quite a while. But overall, what I could do now, if I want to stay in C++, is to use this as a role model, this code and the project, and upload that into an AI LLM, and then say, okay, this is what I want you to do. Reallocate these new set of these um, new set of uh, instruments using these specific type of strategies. Here's my capital, blah 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 blah, and do all that, and just as part of the prompt, use this as use this as a role model, and boom, you'll get a new code base and a new project that you can use this code base with. So it's that powerful. I think this can be very useful for people. Okay, so we're done. So let's go into the code here and visit some of the highlights here. So when I first originally do these type of projects, I can get a structure because I was going through many hours of pain. I just couldn't handle having all the code and subfolders. I mean, you could technically do that and it probably would make sense, but the code is pretty small, so it's somewhat easy to maintain. Um, and you know, there's already an include directory in here, I believe. Uh, I don't know. Anyways, so this is really cool. So what we have here is you can see we have a header and a source file for connecting into interactive brokers. We have the instrument code and the header for that. We also have a forecasting engine as well. And this is 100% generated by AI based upon my prompting. Okay, we have the color console. So all the coloring you see here, that's uh, included as part of, because I specifically want to see that because it helps just for visualization. We have the back testing portion, the app as well. So let's see. I think there's this, yeah, there's the strategy as well, and the trading engine itself. So let me just show you. I'm going to assume people know how to use C++ and understand the concept of headers. So I'm just going to look at the source files, the C++ source files. I think one of the more important ones is when I used to try to hand build CMake files, it was a pain in the ass. But the beautiful thing here now is that you're able to ask the AI to build and deploy uh, the project for you as part of the prompt. So that will include the CMake file or specifically whatever methodology you use to build C++ projects. You could also do it with Visual Studio. You could do it also with VS Code. As I said, to me, it's a pain in the ass. I used to love Visual Studio. Now I just find it's just bloatware with all these different languages they support. It's just too much of a beast. I can't make heads or tails out of it. Whereas you use a specific IDE for the language, it's simpler, and this is what I'm using CLion for C++. Anyways, let's go back into the code here. Um, so I think one of the more important things I want to show here for learning is the actual strategies. So remember, we got here two types of strategies. We have a bear put and also um, what's the other one? Well, we'll find out here in a minute. Okay, yeah, it was an iron condor. So an iron condor is very difficult. That's a more difficult type of option strategy to work with. So in here, you can see here. Hang on here. Let me get to the top here. As you see, I don't use IDEs like I used to. Um, Change around some of my real estate here. Okay, so I think that's the only header we have is the strategy header. But here we have our base class, our Iron Condor class set up. Here's your parameters, and again, all generated by AI. Again, only using Claude. I'll be putting up another C++ uh, project developed by somebody else that put quite a bit of time in it. He developed it using, I believe, ChatGPT, corrected it uh, with Copilot on via I think it was done through Cursor or VS Code, one of them, and it's specifically for Visual C++ on Windows. So it's going to be a total, but it's the same similar prompting and generating what he did using my executive summary file and be able to generate with the same prompt that I gave him and generated it specifically for Visual Studio and C++ or whatever VS Code Visual Studio. Anyways, we have here Iron Condor. So these are our parameters. So we got the instrument. So it's very generic, which is good. We have the upper call strike. We have our lower call strike, our upper put strike. Sorry, upper call strike, lower call strike, upper put strike, and our lower put strike. So I kind of hinted that if you looked at the Mumu presentation, I went through that. Again, that's on my GitHub, and I went through what these puts and strikes and all that fun stuff are. So in here, we calculated. So we have an entry point, and then it looks like it gets a current price. So that's going to be part of the instrument class. So we calculate a take profit. So here we take profit is usually a percentage of the max profit. For simplicity, we'll set it to 50% of max profit. So here is it could get very interesting. Um, if you have a baseline, let's say C++ project, and part of the prompting is I use as little dependencies as possible. Once you start to add in the GUI part, like if it's in my case, I am GUI, you're further complicating the coding, more errors. I also try to build one using a JavaScript front end as well. It just gets too complicated. And part of the thing is you want it clean and very simplistic. So you want the code, especially in C++, to be self-contained as much as possible, meaning there's less dependencies available. And this is the same mindset you want to take when you are dealing with, dare I say, lower latency on top of you have control over the math libraries if there are any, or just any architecture that you want to own the source code on that's banged out by the AI. So here we have our premium. We have a take profit again at 0.5%. So here, what you could do is where it gets very interesting is you could have a separate agent maybe that is looking at the current market, okay, and then you can dynamically set this 0.5% target goal, just as an example. So you can make it more complicated. And the thing is, with an agent, an AI agent, you could do that. You may be able to do extra things through an MCP or a RAG application. So you could go really deep on this and really have some sophisticated trading um, as well. One of the other advantages when you use certain tools on the AI, like Claude, the key here is if you're going to build a major app project, let's say a complete platform with all this extra AI, if it's a RAG or an MCP server, you need that history so that the AI can work with it. You bring in some new code or modify the code and you get new errors. You want to be able to uh, correct that code in the whole project because it gets very big. And trying to maintain that via AI is pretty complicated and pretty tough to do. And remember, if you're using a very uh, more advanced AI LLM, let's say Claude 4, and you need to run it for correcting with bugs or um, some kind of exception or error in the build, yeah, that'll get very expensive as you run more of that. So I think what's good is to start with a baseline uh, project, something like this, and then manually modify it instead of using AI because this is where you got to be accomplished, C++. But the good thing about projects like this with AI, you can use them to basically uh, reverse engineer for learning purposes. So that's reverse engineering if you're new to C++ or Python. Plus, you can also see how these strategies get built by the AI. And these are usually going to be done in a fairly proficient and efficient way as well. So going on, so we set a target here. Here we have the calculating some form of stop loss. So here you can see, and it's important to understand that the comments are there, so you know what it's doing. I could put a README in there, a README text file, and have the AI scan the whole set of code, and then say, give me a coding breakdown of all this stuff, and it'll go line by line or snippet by snippet and telling you what it's doing. You could do that, but here's it's good enough just to work on these simple or sorry, comments that you can reverse engineer. So here you go. Stop loss is usually a percent of the max loss. For simplicity, we'll set it at 150%. So here uh, you can see the calculation. So it's fairly simple to do this. Set a max profit or max width minus the premium. Stop loss set at 50% again, and so on. Here, this is the beauty of it, is that you get to see the breakdown of strategy code when it comes to options. And then when you start to go more in the advanced quant stuff, this is where you start learning. I've been doing this for 14 years, and up until the world of AI, this was not possible. Where you have to learn and understand at the same time the coding and the math front with the formulas. And usually, if you try to code that up manually, you're going to be wrong and you get wrong results, so on and so forth. You could kind of do it in a pricey tool like MATLAB, maybe R, MATLAB for sure, because it has also the professional toolboxes along with the accompanying documentation that was there as part of MATLAB, which made MATLAB, right? That's why a lot of banks use it. And you can reverse engineer it. But here, it's much cheaper now, and you can have the AI generate all the code you want using the formulas that come with the quant, apply them into something like Python, or maybe better yet, to do it in C++, because you get to see how it works, and you get to see um, the math behind it as well. And then the best thing is if you're using a good IDE, whatever it be, in my case here, obviously CLion, you can set it up and then go through the tracing of it, setting breakpoints via debugging. That's the best way to learn, not just the coding, but also the best way to learn quant as well on the reverse engineering of this. Okay. But you can see here it's calculating the expected profit. This is the beauty of it. So here we have our current price. We've got our, in the instrument class where we already have the implied volatility. We have the probability of profit. So here, simplified calculation in reality, this uses the option pricing model. So in that case, we could probably use something like Black-Scholes, or again, as a breakdown, maybe HFT shops have their own customized models. Okay. And again, I'm talking like these shops so that people know uh, how it's done and how to really learn as another way of helping yourself, not just to learn for career, but also learn if you decide to do this on your own. Okay, so we have our probability of profit. And again, that could be another model or formula that could use something like the expected return for my executive summary and build in those that code that will calculate that. So this can be very dynamic as well. That's what I'm saying. It doesn't have to be hard coded. If current price is lower than the call strike and the current price is less than the upper put, the probability of profit is 68% minus the implied volatility divided by 2, and that is price is within the profit zone, an approximation uh, based on normal distribution. And again, right there, you can add on another custom formula and add that dynamic if you want, and or make it more dynamic. Again, here with the max and the min as well, and the probability of profit. So again, this is as close as you can get as similar to uh, the HFT shops. Usually you're using the standard C++. This is using, when you open these projects in CLion, let's say, it will give you an option of what compiler you want to use. So normally, maybe a lot of shops are still on C++17. Some may have already, or a lot have already moved to 20. So this is C++20. And there's options for the newer ones of 23 and 26 for the C++ compilers as well. And that's the other good thing as well. So when you use an IDE, maybe something like CLion, it will give you all the warnings as you go. Plus, you get access to all the debugging and all that. It's very powerful. Okay, so here's our probability, blah, blah, blah. We calculate the probability of profit. Again, I'm not going to go into the formula of it. And then we return them what the max profit is with that probability of profit minus the max loss and all that. Okay, so boom, like we're learning how to, believe it or not, how to do an iron condor strategy in C++ generated by AI. That's powerful. It blows my mind that there are people still out there that say AI does not work for trading. I think you got to be an utter uh, lemming that is so behind the times. It just does not see the power of this just for learning, let alone allowing the code to get generated by C++ and seeing it instead of working with some platform, working with some closed off library. You can generate the code yourself and technically own the code yourself and have an open source that you can go through and understand, reverse engineer, because that is powerful. Now, it doesn't mean you have to go out and release the code, but for your own use, you can do so many things with this. So here we can do backtesting functionality as well. So we have a vector here on the historical pricing that gets passed in, and again, that's coming in from strategy performance, iron strategy. Okay, that's just okay. So we have here our check if it's empty or not. We build out a new vector, blah, 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 min, max, P&L, run it through a loop, blah, blah, blah. Anyways, it's pretty well self-learning, but it's right there. I mean, this is powerful stuff. So here we have a performance class. I mean, this is unbelievable what we have. We can calculate our sum of our P&L from the beginning to end. Again, we're using here um, standard, right there. Yeah, so there you go. You get your equivalent of IntelliSense in CLion. And let me remind you as well, IntelliSense is free. Or I'm sorry, CLion Community Edition is free. There's no restrictions as long as you are not using this for commercial purposes. This is for self-learning. Okay. So here we got the math going on with the inner product. I mean, this is unbelievable what you can do. Okay. And you can have AI as well to generate. Here's the C++ function. Make it more optimal in terms of speed, meaning that you can maybe uh, bypass a standard um, library and maybe use some very, very technical uh, HFT techniques I've shown in my book that you can apply here and have the AI generate it. I have seen one, I think it was DeepSeek, and I was able to generate FPGA level code uh, just for fun with it. That was back in the winter in February. So you can imagine what you can generate now, telling it to include code for a very low level. I'm sure AI can do it, especially now the new ones coming out. Um, but again, here's all the math involved and explaining it as well. This is really good. And again, this is for self-learning. Okay, so right here, this comment is generated from the part of the iteration as a self-correcting. So you might see some of that code as well. Um, but I'm not going to go on about this. This is pretty powerful. So now we are moving into the bear put as well. Right here, that's set up on the new bear put as well class. Like this is really, really, really good. So there's a constructor, and then the calculate entry point, take profit. Uh, yeah, this is really good. And you can reverse engineer all the math you want. So this is complicated option strategy code using AI. Unbelievable. Okay, so let's go into the instrument here. Let's see what it's doing. Okay, so we have an instrument. We pass it a symbol, a type, sorry, contract size, and tick size. Pretty self-explanatory. We have an option chain. Wow, 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 wow. Okay. So again, we can, as we iterate through this, we can add in all that extra code. Um, yeah, this is powerful. Okay. Um, so that's the instrument. Here we have the forecast engine. Let's see that. So we have a vector here with a class, forecast price path. Um, I'm sorry to tell you, I just don't see now. I think just thinking about this, like what advantages do all these Ivy League schools have when you have now the AI to do exactly what I'm showing you to reverse engineer um, and then use mathematical skills. And I've been able to generate code from research papers, from blog posts. It's pretty impressive and it's so advanced now you can now, from what I'm seeing, to do C++. Okay, so just unbelievable. So here you have choose a forecasting method based on available data. So we could feed in the real world data. We have here the implied volatility gets calculated. So right here, this is how they do it. All the math behind it. If current IV is not available, estimate it from historical price volatility. Now, people are going to go, is that valid or not? I can't say. Um, but again, you can always pass it through different various LLMs, different versions, and I can't say if it's going to be accurate or not. This is just a baseline, okay? You have to remember that. This is not going to be a way to make money just because you have AI. Like there's a lot of iterating involved. and verification. And as I said, as you build out a very comfortable baseline project that you want that could eventually be like a platform, you could do that. And as I said earlier, you could add in other new functionality if it's AI driven through MCP, RAG. Um, the world's your oyster at that. I will say one of my projects I have for my Quant Lead members, I did ask the AI, Claude again, to generate a full-on trading platform, HFT, ultra low latency in mind, with that in mind, and use trading agents. What I will say, using what we're showing you here, uh, is the old way. If you add in the agents, all this extra functionality are agents themselves. So you can build agents upon agents or MCP or RAG upon any of those combinations. You can do that with the AI calls built in, and you get those results that you want. So what I'm showing you is the old school way, where I think now, uh, including trading platforms, and I guarantee you this, a lot of HFT shops will not do this. The banks will not do it. The hedge funds won't do it. If they're running on legacy um, code um, that's like decades old, which they won't change because it works. It works for them. It's still making a lot of money. That all that code, I'm not saying it's going to become obsolete. It just is going to be kind of like the equivalent of COBOL from the 60s. Because now in the future, I think full on enterprise level trading platforms in shops will be built in with and architected with trading agents in mind. I have a project that I built that on. It's a complete mind F, we'll say, to really understand that, what's available, and then to build all your extra features through the agents. And it's very seriously complicated code. I couldn't imagine what it'd be like also trying to do that with a low latency in mind as well. So I don't know. It's really a fascinating point where we're at right now. When we're starting to implement AI, we're starting to see some very advanced AI models come out, and we're on the verge of this chat GPT-5, which they promise will supposedly scares even Sam Altman because it's so accurate. But I've read and saw a Medium project that speculated on where ChatGPT 5 will have all this fancy dancy things in it from a coding point or code generation point, and it clearly stated that they're trying to target Claude 4 reasoning. So ChatGPT is trying to catch up to where Anthropic's at with the Claude 4. I have just kind of experimented with Claude 4 Sonnet reasoning and Claude 4 Opus or Opal reasoning, and it seems to be coming down in cost. Okay, I think we're going to be at that point now between those two providers, and plus with when Meta gets their act together for AI, Grok comes along. Um, the pricing to run all this will be dropping, so we'll be able to do a lot more experimenting across many other LLMs, and let alone if you don't know with what Quen's done, or I think it's Alibaba has brought out a coder, Quen 3 coder, that's open source and it's free, and I've tested it, and I have to say I was very impressed with it. It's about 70%, maybe 75% of where um Claude 3.7 reasoning's at. It's pretty close. But then again, from what I'm seeing, or I hope to see, that the difference between Claude 4 and Claude 3.7 with both reasoning will just blow the doors. So what I'm saying is Claude 4 is, with reasoning, is going to be like light years ahead of uh, whatever LLM's out or will be coming out. Sorry about the rant there. Anyways, continuing with the forecasting here. You got log returns. So part of on the math front, on the quant front, the math is not that difficult when it comes to quant. So here we're doing a log return. Um, yeah, so it's using the standard log routine. And some of the shops will take out the standard library and have their own mathematical routines. uh, just because they want it to be faster. But as I said, with whatever comes out with with the AI and agents in mind, it's going to be radically different soon. But there you go. There's the math as well. Pretty cool. So here we can forecast with a slight mean reversion to long-term average. Can never read this of 20%. So again, you can dynamically change all these based upon what market conditions are and using AI for that. And you can do that on the fly. I mean, it's absolutely uh, blows my mind where we're at. So you can see here, here's our IV or implied volatility that's forecasted based around this. I remember trying to hand code this and using other coding projects I've seen online. I don't know if they're right or wrong. I just don't know. But here, I'm going to put a probably a pretty good confidence on this. This is pretty accurate, I would hope. And again, here you have your working days for your trading days of the year. So again, it's there. Just got to make it more generic or maybe AI driven. I don't know, but it's pretty powerful with where we're at right now. So again, we can forecast a strategy. So we have our strategy we can pass into as an object or a class, number of days and forecast on that. I mean, this is part of the thing that I think Python can really stumble at because when you look at multi concurrency parallelism, Python's not built for that. C++ is. C++ is also built for true object orientation, and that's what you're seeing here. Classic object or oriented object programming. This is what we're talking here. So this is all classic stuff. Calculate exponential moving average. Unbelievable. Okay. So again, I'm not going to go into this. We have an EMA, all not hand code, AI generated code. Okay. And again, forecast using SMA, um, forecast engine for calculating linear regression. Jeez, all that there. And it only generates code for when it's needed. So in this case, probably both the Iron Condor or the um, Bear Put needs this type of mathematical code. So did we look at the instruments? I think we did, yes. Portfolio. Let's look at the strategy code. Okay, so this is the other big thing with strategy code, where it could be dynamic. Let's see what kind of stuff we have here. So we have a vector based upon historical prices. Um, we have our cumulative P&L. And again, I ask for that in my prompt. Okay. So the prompting is key here. Okay. Just to put it out there, I had somebody on the Moo Finance meetup ask for my prompting. I kind of laughed and he laughed. Well, he said, I guess you're not going to give it away. And I said, no. And everybody in a good number of people in the room said, oh, no, he won't give away his prompting. So expect that. I don't give away the prompting. I've been spending many months on this and probably good a couple of probably $1,000 so far to get to where I'm at in cost. So why would I just freely hand that off to people when this is my full-time income? I don't have a job in some university. And I do this for fun and give away stuff and run it as a charity. Sorry. Okay, so here we have again cumulative P&L, max P&L, min P&L, and that's part of, as I said, part of my prompting goes through the historical pricing. And unfortunately, there's no comment here, so I don't know what it's trying to do here. We get a current close, daily return, daily return. Oh, I see. So it's generating the cumulative profit with the daily return, and then it adds it to the daily return. Then we get a max and min P&L. Very cool. Then we add some performance metrics here. Okay. We got the volatility. So these are the clear metrics that I've shown when it was running. Okay, that makes sense. Here, yeah, we're calculating the volatility, and right there, there's all your math in an array in C++. That's pretty good. And then we, as I said, we have the performance metrics here. Um, so we have a strategy performance for the bear put strategy. We forecast it across days, and you can tell it's making it as generic as possible. Um, if you looked at my Streamlit code, you'll clearly see there's more hard-coded uh, code in there. That those numbers come in from the executive summary. So if you remember, what I'm doing is I'm taking all the single instruments found on the CME, have institutional quote unquote level um, stats run on it, and put into its own Word doc or whatever format you want, and then take those 40 plus instruments and then feed it into an executive summary, and it will come up with an overall set of strategies that could be applied to that data, um, and then build that executive summary on telling you what it would do if you said in the prompt, here's the starting initial capital, and here's and asking for the optimal allocation of weighting for the within that portfolio, and what strategies to run. So part of that, you will see that in the executive summary in that Streamlit app. And then out of that, as I said, you want to focus on those instruments that have the highest potential expected profit. So these are the ones I've shown you, the instruments with natural gas, oil, and I think the other one was cocoa and silver. So here we've got two strategies. So part of that was identified. We're using two separate strategies here in the futures and options, a bear put and the iron condor. Okay, and you're getting the source code with it now, and then it's in C++. That's the absolutely incredible thing about this whole process. So now we're going to look at how it's done in the bear put. Now, this is what a lot of firms will be using because, as I said, they will be working with strategies uh, for coming out of futures and options. And that's where they generate most of their profit. And as I said in my meetup at Moo, is that roughly about 80% of the choice between future and option will be option. Okay. So even in the strategy selection out of what I feed it from the executive summary, usually it's going to be involved more options than futures. Mind you, I do have a course on all of this futures and option stuff. Okay. It goes very deep. And again, this is what you need to go into trading. And as I said, if you want to stay in the game and get the absolute highest uh, salary, it's going to be portfolio manager. Okay, outside of getting into the upper executive in the firms because they pay out in the millions. And here we are, we're doing all the quant stuff. We're talking about the trading, and we're also doing most likely the language they do it in, C++. Okay, so what you're seeing here is how they do it. This is what the quant researchers will do, and they'll optimize using, and probably it can safe to say that what a quant researcher does, AI can do it as well. It just depends how you architect these type of, I don't know, call them platforms. Could be a platform or a baseline project uh, platform, we'll call it. So here we have the strategy performance on the bear put. Okay, again, all the current price, probability of profit, and again, these numbers here could be dynamically generated using AI or uh, another routine or function on another class. I'll calculate all that for you. Okay, so here we have all the performance metrics that we've talked about that I've asked as part of the prompting win ratio. What's that? Win ratio? Yep. Sharp ratio, volatility, max drawdown, max profit, and max loss. As I said before, if you've never watched any of my stuff, these two are probably the most important things you want to look at when it comes to backtesting. I've shown many instances now where we can get the AI to do backtesting for us. What we're looking for is when it comes to over a period of time on the trading performance, we're very concerned about max drawdown and concerned about volatility. And we're going to obviously choose the ones that have the lowest of both, but with the highest profit potential. Okay, that's the whole name of the game of this. We don't want to have capital being deployed on something that will either be subpar profit or be a money loser. And these are the two metrics you can use uh, based on based on past performance and being able to forecast it. And here you can see it's using the implied volatility as well. So that's it. So this is smart money in action. Let's see in the trading. Okay, so I don't know if we've looked at this code here, the forecast engine. Yeah, we have. We don't care about the dashboard. Let's look at the trading engine now. This looks pretty big as well, but I'm sure hopefully you're learning away. So here we have the trading engine constructor. We're starting here. So it looks like I probably will look at the dashboard code. I think this is threaded to run on its own. And again, I hate to say this, but to run this in Python, no, it's just sheer madness. I'd rather put the learning into C++. As you can see, it's kind of straightforward once you start to reverse engineer it, and especially when you're not using other third-party dependencies, libraries. Okay, so here we've got positions, we've got our entry price, profit level, stop loss. So we get our market data, and then we process the signals. Those are usually the steps taken on these strategies. Get our latest data and market data, and then process the signals from that. Okay, so we do a stop on the engine. Yeah, so here you can see it's going to execute your strategy. So whatever your strategy you have, which will come from here, okay, so that will be either in this case the bear put or the iron condor. And here, as part of the strategy, we'll have already calculated an entry point, or will calculate an entry point. We will already have calculated our take profit, and our stop loss will also be applied. All the basic metrics when it comes to any trading decision. So we set it here within the strategy, um, and then enter the position if there is an entry. So here's our monitoring on the positions. I believe these will be, well, let me go through the code before I make that decision. Get current market data, unrealized P&L. What's our strategy type? So we could have a iron condor or a bear put. So these are specific to the strategy. So we have here specific conditions for both the iron condor or the bear put. Theoretically, you would try to make this as generic as possible. So let's say um, you want to add in a third strategy, some kind of arbitrage. Here you want to just say if strategy equals that strategy type. You'll have another call externally to set up all of these necessary uh, um, variables within the class. Okay, so we have our entry points based upon the strategy, our take profit based upon the strategy. And again, using take profit level uh, proxy for width. Okay, here's our current price. Okay, and within the profit zone, uh, unrealized profit. So here, this is now um, the unrealized profit for bear put. Similar coding techniques here as well. If somebody had real difficulty to understand this, The best way is just to run it through a debugger. Okay, that's the best way. Check if profit uh, or stop loss is hit. Okay, so we have our target here, and then exit the position if either is hit, stop loss or the profit target, or take profit target. So we update the market data. This is how usually these big platforms are running. Uh, get instrument current market data. So here again, you usually want to make these generic as possible, but here it's kind of hard coded in, and I don't know where these numbers come from. These might be coming from maybe the executive summary. I'd have to look it up, but okay. So update imply. So this is it sounds like it's hard coded. If the implied volatility in real implementation, this would come from, let's see here, I missed that. Oh, from the option chain. Wow. So these are implied volatility hard coded, I believe, from the executive summary. So again, you'd want to make those generic. So my whole point here is because we've got four major steps involved in generating this particular, call it platform. Um, as I said, you've got 40 instruments. All those reports get generated, all fed into a executive summary. And then we create the Streamlit Python app, and then trying to identify all the targets. So this is part of the targets, hard coded from either the Streamlit or more likely from the executive summary. That's very interesting to do that. Remember, this is my first time looking at this whole end-to-end uh, workflow, because that's what this is really when I'm talking about these four steps. It's a workflow. So if you're able to automate and have the this kind of code generate all this fun stuff on the fly in a real world environment, generating all the instrument reports, generating the executive summaries instead of me doing it, and then feeding it back into um, a complete set of automation. I could automate this with basically what I'm saying and have it self-adapt based upon the instruments, and hopefully at some point may have a complete trading system that will run on its own, self-adapt, and readjust everything. That is very likely I could generate using AI, make everything dynamic and self-adapt based upon this workflow I'm talking about. So that is very likely I could do that. So we update the option chain, and as I said, the most important thing out of the whole process here is the option chain, because you don't get that with any other asset class. You don't get, if you're in the spot market, you will not get access to future data in a spot market in crypto. You will not get the same in the spot market of Forex or equity. It only comes out of the options chain data. The thing is, when it comes to the CME, the is very strict and restricted when it comes to anything data-wise running through the CME. It cannot be manipulated. There's no way. Um, but if you're getting it through a broker, I don't know where they're getting the option chain data from. So, and it's not going to be as tightly regulated as well, I would think. Um, so I'm not sure where that option chain data comes from within stock, but my point here is that the option chain data is so valuable because it basically is a reflection and gives you real world market sentiment of future market sentiment based upon what other traders, retail that are doing this, or firms that are doing this through the option chain data. This is why when somebody says that AI fails, because they do not understand the concept of when you are building an AI and building for market prediction, only using either current or past data, Yeah, it won't work. That's guaranteed. But it may not work 100% with option chain data, but you have a much higher probability of being accurate when forecasting using AI with option chain data. There's no doubt about that. Okay, I think in the room that when I said that, I think a majority of people agreed with that. So if you hear somebody say, "Oh, AI does not work with market data because it can't forecast it," we'll ask them what kind of data it is. If they're only giving you historical data, they don't know what they're talking about. Okay, any professional institution will tell you exactly what I just said. If you are using the option chain data to forecast with, that's true data from the exchange, and that's not going to be manipulated. It's not going to be speculated. That is how their traders and their ecosystem are making those calls. And when it comes to large exchanges like the IC, like ICE or the CME, that's tightly regulated by the government. So they're not going to kind of screw around, nor will they screw around because many firms are trading billions of dollars, probably trillions of dollars through these exchanges daily. And they can't afford to lose the credibility if they are caught being manipulated by somewhere. It is a pay to play, yes, but the data itself should be sound. So here we process the signals in the trading engine. This is another key point. So we calculate our expected profit. Um, yeah, so execute the strategy if it's greater than 0, the expected profit. Monitor all open positions. Uh, Pretty powerful. So we can do an entry point here. Okay. So if strategy is enabled, an active position strategy return. Uh, I'm sorry, that's the same function here. Um, get the instrument, get the symbol, get the allocation, get the current P&L. So here it's about to do the trade. Okay. So here it gets the quantity, how much we're going to trade. The quantity, not, well, the price is based upon the quantity and the actual future cost of the contract. You get type, and again, with Iron Condor, so here we print out all of the necessary things it's doing, either depending upon what side or what strategy. So we have the bear put along with Iron Condor as well. Buying, selling, blah, blah, blah. Active, entry prices, trading exit. So that was the entry. So now we do the same thing on the exit. This is how a lot of firms will do it very similarly. So this is a powerful project to get access to. So like I said, we need to look at the dashboard because I have a couple of questions there. Okay. So in the dashboard, well, let's see how the main runs and how it kicks off all this stuff. So in the main, you have initial capital. Again, that can change because we have a toggle for that, as I showed earlier. Um, so looks like we can pass in with line arguments the capital, starting capital, initialize and run. Okay. So is there an app? Yep. So here's the app's code. Um, yeah, this is the first time I'm looking at this. So this is a complete system. So we initialize everything, all the new classes and new objects, connect into them. So we connect into the IB, set up all our portfolio fund stuff. And here's the thing, we set up our whatever strategies we have in the system, which is going to be our Iron Condor and Bear Put. Then this is the key here, is we're establishing new objects, instantiating the trading engine along the dashboard. Okay, so then we can run it. Yeah, start here and handle user input at the same time, and then shut down, tear down all this fancy stuff. So as you know, with the new versions of C++, this is the weakness of C++, is managing all these objects by instantiating it with a new and then a delete. If you don't do it properly, a thing will go haywire, and that's where it brings in all the vulnerabilities you hear about with C++. Especially when it comes to live money, that's another big factor too. So everything has to be 100% rock solid, and that's why a lot of these multi-billion-dollar firms don't want to change their code because of the risk that comes to changing the whole architecture of this stuff. So I don't know. So basically, this is all tearing it all down as well and nulling out all the objects as well. All right, so we set up our instruments. So yeah, as you can see here, uh, we have oil, silver, and natural gas. All right, so here we default to these implied volatility, current price. Again, this is hard coded for whatever reason. I don't know why that is. I'm sure that gets overridden anyways. Um, Adding the instruments, mapping, and so on and so forth. Setting up the strategies. Okay, that looks pretty simple. And again, it's better to make all this dynamic if you can. So this is kind of hard coded. The CL, SI, silver, natural gas. Um, but this is all for learning from the simplistic point of view. Then we have a portfolio set of objects. It would take me days to go through breaking down the code. But again, um, it's not that complicated once you understand the style, and to be able to reverse engineer it as well. Um, let's see here. So we want to see the dashboard here. Uh, okay. So these are pretty involved. Okay. And then we have okay, so this is the key here. I've not tested interactive brokers connectivity with the TWS. Because you're using C++, it opens up a few more doors for you. You can use the gateway, and that would probably prefer to use uh, in a Linux environment. I mean, obviously you can do it in Windows as well, but the gateway can be used definitely in the Linux environment, and more specifically, you can go extra complicated if you want to use the fixed protocol. If you really want to get into high level salaries in the big firms, you'd want to go with a fix. If you're going to do the fix on your own, I just read somewhere it costs 600 a month for that kind of connectivity with interactive brokers. But once you start mentioning fix, then you're going institutional level. With other brokers, if they don't offer a fix option, then the question becomes, well, if you want to go professional, bigger, like 6-digit account level, you probably want to go with interactive brokers. If you're going to stay in, dare I say, Robinhood or any of the other smaller brokers, you'll be trading with the retail market. But if you want to move career-wise, you definitely want to probably do something like interactive brokers that will give you over time fix option. If you get a bigger account, and understand these sort of things is going to be looking pretty good from a recruiter point of view. Doing all this stuff, and more importantly, to be able to demonstrate you have a profitable strategy or set of strategies, or being able to run money against different types of instruments and get profit. Okay, so I'm assuming, let's see, I'm not sure how this is connected. Yeah, right here. So it looks like it's connecting into the host and the port. So that would be TWS, I'm going to assume. Um, yeah, it's all basic stuff here. So I don't know. I'm not going to test it in this one, but probability says you maybe will get something running. My next video breakdown, I'm going to look at, as it says, going to be using Visual C++ along with um, uh, in Windows, and that was generated by a totally different LLM. Same prompt, but to see how that looks differently. Okay, yeah. So there you go. Nothing out of the ordinary there. So that's pretty well it. It's pretty long, as I said. If you hear, I'm pretty impressed. So that's an hour. So if you go to my quantlabsnet.com, we're going the HFT route, maybe. But if you want to know things about how to get a free ebook on C++ HFT infrastructure, uh, sign up. I don't give people's information away to anybody. And here you get entered into my newsletter and you'll see what I'm doing, all the projects. I've just put out two with Python, and I'm going to release this one, and you only get it on my website. Um, and I'll also do a separate one for the Visual C++ from the ChatGPT and Copilot. All right, so we'll leave it at that. Thanks for watching. Have yourselves a good day.